Hello everyone. What we'd like to do in this video is take the sine and cosine graphs and shift them left or right. This will be the last type of transformation we talk about for the sine and cosine functions. So if I'm thinking about shifting a function left and right, regardless if it's sine or cosine, since I'm doing some sort of horizontal transformation, notice that I'm somehow affecting the x values of the function. So I should think that I should be doing something to the inputs of the function. So recall, let's say for right now that c, we have c is some sort of positive number. And let's say I add a constant c directly to the inside of the function, or I add a constant directly to x, versus if I subtract a positive value c from the x value. In this case, what's going to happen is this is going to shift f to the left by c units, and if I subtract a positive value from the x value, this will shift f to the right by c units. Okay, so I remember when I first learned about these horizontal shifts, this really threw me off. It made sense to me when we had a function and we added a constant to the outside, or if we subtracted a constant from the outside. I'm taking my outputs and I'm adding a value to them. This should shift the graph up. I'm taking the outputs of my function and I'm subtracting a value. This should shift it down. However, with these pluses and minuses, with horizontal shifts, they seem backwards to me. Intuitively, I would think if you added a constant c, that should shift it to the right. If you subtracted a constant c, that should shift it to the left. It's backwards. It's the other way around. But if you really think about it, this has to be true. And the one example that really helped me when I was first learning about this was thinking about the absolute value function. So if we have the function, the absolute value of x, if we sketch that really quick, the absolute value of x looks like the classic v. Well, let's say I have a different function, let's call it g of x, and let's say that's x minus 3, and let's have, I don't know, another function. How about we call it h of x? And how about that's, I don't know, x plus 2? Well, if we're thinking what's happening here, specifically for g of x, I'm always paying attention to kind of this kink in the absolute value. Notice here, for the absolute value, if I plug in 0, I get an output of 0. 0, 0 is the location of this kink in the absolute value graph. Well, what value of x do I have to plug into here to get that same output of 0? Well, I have to plug in 3 to get an output of 0. So I have to plug in 1, 2, 3. I have to plug in 3 to get to that same location of that kink, or to get that output of 0. Okay, so this is shifting the graph to the right. And the reason why this makes sense is because I'm subtracting 3 from my input. I have to plug in more to get here. I have to plug in more to get here because I'm taking something away. Similarly over here, well, what value of x do I have to plug in to get the output where this kink should be? I should have to plug in -2. I have to plug in -2. So since I'm adding something to my x value, I have to plug in something less to get to this kink. And that's why it's shifting it to the left. So this always helped me. Okay, so let's go ahead and let's do some examples. Now it turns out that when we're sketching these graphs, or sketching the graphs of one period of these transformed sine and cosine graphs, the horizontal shifts, they're a little bit tedious. But this is the best way that I like to graph them. Okay, so let's say for example, let's give ourselves a little bit more room. Let's say for example that we want to, let's graph one period of, let's see, the following. How about y is equal to 3 times the cosine of x plus pi over 4. So we want to sketch one period of this graph. Notice here that I'm adding pi over 4 to the input, so I'm actually shifting my cosine graph to the left by pi over 4 units. Let's write that down. How about in green? This is a shift left by pi over 4 units. Okay. And this 3 here, this will tell me my amplitude. This is a vertical stretch by 3, but really what this tells me is my amplitude is 3. Your amplitude will always be the absolute value of whatever the number is out front. So in this case, that's 3. If there's a negative there, you'll just know it's been reflected over the x-axis. But the amplitude is always a positive number. Okay, so what I'm always going to do when I'm graphing these is I'm going to graph it without the shift, and then I'm going to adjust the x-axis. So the way I like to do these is graph without horizontal shift. First. So I'm going to graph y equals 3 times the cosine of x. Okay, so let's go ahead and graph this. Okay, so here is 2 pi, here's pi over 2, and here's 3 pi over 2. Let's also record 0. We have an amplitude of 3. Okay, cosine starts at the top of the amplitude. Our equilibrium's at 0. So cosine will bounce on these spots. Okay. So here's the graph of 3 cosine of x. Now what I want to do is I have these 5 x values that I basically just need to move. And since I'm shifting this graph left by pi over 4 units, I need to take all these values and I need to subtract pi over 4 from them. So what I'm actually going to do here is I'm actually going to erase my y-axis here. We're going to do a bunch of shifting. So I'm going to erase my y-axis. Okay, we'll reintroduce it in a second. Okay, and I'm going to adjust these numbers. I need to subtract pi over 4 from each of those. Now, something that might make this easier, so we don't have to do, I don't know, so much fraction work, I would try to find a good common denominator that works with 4 and all of these 5 numbers. I would write all of these with a denominator of 4, so instead of a 0, I guess we could write that as a 0, that's no problem. But I'm going to write this as 2 pi over 4. I'm going to write this number here as 4 pi over 4, then I'll write 6 pi over 4, and then I'll write this as 8 pi over 4. So these numbers just now have a common denominator of 4. And I'm going to take these numbers, and since I'm shifting it to the left pi over 4 units, I'm going to subtract pi over 4 from each of these values. So instead of 0, 0 minus pi over 4, I'm now going to get a negative pi over 4. Okay, I have 2 pi over 4, and I'm subtracting a pi over 4, so I'm left with 1 pi over 4. So I'm subtracting pi over 4 from each of these x values. Okay, so here I have 4 pi's over 4, I'm taking away 1, so I'll have a 3 pi over 4 here. 6 pi's over 4, so I'm subtracting 1, so I'll have a 5. Here I'll have a 5 pi over 4. And I have 8 pi over 4, subtract 1, I'll have a 7 pi. I'll have a 7 pi over 4. Okay, so I've subtracted pi over 4 from each of those values. And now what we're going to do is we've basically done our shift. Now we just need to reintroduce the y-axis. We need to introduce where 0 is. Well, 0 is right here, so we'll reintroduce our y-axis. So here we have negative 3, here we have 3, and here is the graph of 3 cosine of x plus pi over 4. Okay, the hardest part about these is really just doing that fraction subtraction or addition, depending if I'm shifting it to the left or to the right. In general, when we're doing horizontal shifts of sines and cosines, we need to be a little bit careful. Now, not just, I guess, with just sines and cosines, but when you're doing horizontal shifts with any function, any sort of function transformation, you do need to be careful. Let me show you what I mean. So for this example, let's say we want to graph one period of, let's say, cosine of 2x minus pi over 3. So now, one of the most common mistakes I see, I'm going to write this in red. Red means bad. A common mistake I see is students seeing this pi over 3, subtracting pi over 3, and thinking, I don't know, here's our thinking face. Here's our thinking face, and I don't know, you I don't know, this is you're pointing. You're pointing at the pi over 3. You're pointing at this pi over 3, and you're saying, oh, this is a shift. This is a shift. This is a shift right by pi over 3. This is a shift right by pi over 3. No! This is not right. This is not right. We have to be careful. Why? Remember, when we're doing a transformation, if we're wanting to shift it left and right, I have to directly affect my x values. I'm not subtracting pi over 3 directly from x. I'm subtracting pi over 3 from 2x. This graph does not shift to the right pi over 3 units. What we need to do is we first need to factor this 2 off of the x to see the true shift. Don't make this mistake. So we want to see the true shift. What was this? This is minus pi over 3. So what we want to do to see the true shift is we want to factor out that 2. So if I factor out a 2, I need to think about 2 times what number would give you pi over 3. I hope you think of pi over 6. So notice if I multiply the 2 onto the x, I get 2x. If I multiply the 2 onto the pi over 6, the 2 will cancel with the 2 and the 6, and I'll get a 3. So I get right back to where I want. So actually what we have here, green means good. Actually, here with a super smiley face and pointing. This is a shift. This is a shift right by pi over 6 units. So be careful. Okay, now let's go ahead and graph this. Okay, so let's give it a sketch. Let me erase our happy face, or how about I write this? How about I write this over here? Give us a little bit more room. Cosine of 2 times x minus pi over 6. Okay. And I guess we can keep the happy face. And you're saying, hey, hey, this way, pi over 6. Okay. So let's graph it. So I'm going to graph this without the shift. We're going to think to ourselves that we're really graphing cosine of 2x first. So let's think about what the period will be here. Well, the period will be 2 pi divided by 2, so the period will be pi. So let's mark that. So here we'll do pi. We'll cut that in half to get pi over 2. We'll cut that in half to get what? Pi over 4. 1 pi over 4, 2 pi's over 4, 3 pi's over 4. Okay. Our amplitude is just 1. So here's 1. Here's negative 1. And cosine starts at the top. Sorry about your legs. Okay, here we go. Okay, so here's one graph. Here's one period. Here's one period of cosine of 2x. Now what I just want to do is I want to take all these x values and I want to move them to the right by pi over 6 units. So I need to add pi over 6 to each of these numbers here. Okay, so I need a good common denominator between a 6, a 4, and a 2. And I think a 12 is going to help us out here. So instead of moving right pi over 6, let's move right. Let's move right. Let's move right. How about 2 pi over 12? Okay, so let's just change these values so they're 12s. So multiplying by 3 over 3, the best trick in the math book, cleverly multiplying by 1. 3 pi over 12, multiplied by 6 over 6, we get a 6 pi over 12. Multiply by 3 over 3, so I'm going to get a 9. A 9 pi over 12. And what will that be? 12 pi over 12. And don't forget the 0 right here. We still have the 0 I should mark. We have 0. We'll just keep that as 0. Okay, we can go ahead and erase. Let's erase this y-axis. Okay, let's relabel. Okay, so I'm moving it to the right, pi over 6 units. So 0 plus pi over 6. So this will be now pi over 6. Okay, I need to add I'm adding 2 pi over 12 when I reduce it to pi over 6. I need to add 2 pi over 12, so I would be at 5 pi over 12. So this will now be 5 pi over 12. This will now be 8 pi over 12. This will be 8 pi over 12. What could we reduce that to? Let's see, 4 goes into both of those. 4 goes into here twice. 4 goes into 12 3 times. Okay, I need to add 2 to the 9, so I get 11 pi over 12. 11 pi over 12. And then what am I going to get? I'm going to get, 14 pi over 12. I'm going to get 14 pi over 12. Or let's see, 7 6. 7 6. Okay, so we've relabeled our x-axis. Okay, now we'll just reintroduce the y-axis. So this is, so what? 0 would be, I don't know, about right here. So here we have it. So this will be 1. And this will be -1. So here's the sketch of 1 period of cosine of 2x minus pi over 3. So in general, just be careful with horizontal shifts. If there's a number multiplied in front of the x, you need to factor that out first so we can see the true shift. Okay, let's do one more example. Okay, so let's graph 1 period of, let's say, y is equal to, let's do 4 sine. 4 sine of 1/2 x plus pi over 8. Okay, how about plus 2? Why not? Plus 2. Sure. And for fun, why don't we throw a negative out front? Sure. Go ahead and pause the video and try to give a sketch of 1 period of this function here. Okay, let's do it. So the first thing I'm going to do is I notice that I have a 1/2 being multiplied on the x. Be careful, this is not a shift to the left, pi over 8 units. I need to factor out that 1/2 first so I can see the true shift. So we're going to first write this as a -4. Let's write this as sine of. I need to factor out the 1/2. And I'll be left with what? X plus, what will be pi over 4 plus 2. So what we have here is we have a shift left. So this is a left shift by pi over 4. This right here is an up shift by 2. Okay, this is telling me my amplitude. So my amplitude will be the absolute value of -4. So that'll be 4. The negative tells me I have a reflection over the x-axis. So this is a reflection over x-axis. And right here, this is telling me information about my period. So this is saying that my omega here is equal to 1/2. Just as a comment, I often use omega here. You may see sometimes the book use k instead. So I'll often use omega, but sometimes you'll see k instead. So they mean the same thing, just a different letter. Okay, so what I'm going to do what I'm going to do is let's go ahead and graph first. Let's graph first a -4 sine of 1/2 x plus 2. So we'll graph this without the shift. Okay. So let's see where we're at. So we have, where's our amplitude? Our amplitude is at 2. I'm actually going to need a little bit more room. So we're shifting it. Okay, so I need more room down here. Okay, so our equilibrium is at 2. So here's 2. Let's draw our equilibrium. Okay, our amplitude is 4. So here is 6. -2. Okay. So let's figure out what our period is. So our period is going to be equal to 2 pi all over 1/2, or this will be, it's 2 pi over omega, or you'll see the book might say 2 pi over k. K, there's just a different letter. So 2 pi all over 1/2, this will be 4 pi. Okay, so let's go out over here to 4 pi. I'm going to sneeze. Or I thought I was going to sneeze. I'm okay. 2 pi, pi, and 3 pi. Okay. So let's sketch our graph in this window. So let's see. Sine normally starts at equilibrium, so we'll start here. And sine would normally go up, but it's reflected, so it's going to go down. So here, then here, then here, then here, then here. So we have our graph of -4 sine of 1/2 x plus 2. All we need to do is we need to take account for the shift. So what I'm going to do is I'm just going to go ahead and erase the y-axis here. We'll move it in a second. So we have a 0 here. Okay, what do I need to do? We need to move it to the left by pi over 4. So let's all make these be, have pi over 4s in them. Let's just keep this as, and we'll just keep that as 0. I mean, I guess you could see it as 0 over 4 if you'd like. I could see this as, 4 pi over 4. I'll see this as 8 pi over 4. We'll see this as 12 pi over 4. And we'll see this one as 16 pi over 4. Okay, so what do we need to do? We need to subtract pi over 4 units from those. So we need to subtract pi over 4. So this will now be a negative pi over 4. This will now be 3 pi over 4. Okay, this will be 7 pi over 4. This will be 11 pi over 4. And this will be 15 pi over 4. There we go. We've shifted all these points. Okay. So now what we need to do here is we just need to reintroduce the y-axis. So I would say, so there would be like, if I'm thinking about from negative pi over 4 to 3 pi over 4, that's like, if I add a pi over 4, I should be at 0. So it's like 1, 2, so I should be at like 0, 1, 2, 3. So I don't know. I would say roughly right here should be 0. So I'll draw that. So here we go. This is where the y-axis would be. So we'll record the 2 here. We'll put the 6 here. And we'll put the -2 here. And there we have it. There's a graph. There's a graph of our function here, y. -4 sine of 1/2 x plus pi over 8 plus 2. Okay, beautiful. Awesome. I hope you enjoyed this video. What we're going to be doing in the next one is, given a picture of a transformed sine or cosine graph, can we come up with their equation? We'll see you there. Take care.